Hello everyone and welcome back to the channel. We have just wrapped up the biology and the chemistry section of SVNIRTAR CET 2024 paper. Hope you found those helpful. Now it's time to dive into the physics part. Get ready for some interesting questions and clear explanation coming your way. Let's jump right in and crack the physics section together. Let's get started. So the very first question is, which of the following has same dimensions? Option A, torque and force, B, potential energy and force, C, Planck's constant and momentum, and D is torque and potential energy. So first let's analyze the options by checking the dimension of each physical quantity. So number A, that is torque and force. So we know torque formula is force into distance. So let's put the dimension of force and distance in it. So we will be getting here mlt minus 2 into L, that is distance. So we'll get here ml2t minus 2. Next, force have dimension mlt minus 2, so they are not same. Next, number B is potential energy and force. So potential energy we know is ml2t minus 2 and force mlt minus 2. Next, third one is the Planck's constant and momentum. So we know Planck's constant h has dimension of energy into time, so it will become here ml2t minus 2 into t, so it will become ml2 and t minus 1. Then momentum, that is P is equals to m into v, it will be m into L t minus 1, so it will become mlt minus 1. And last, number D is torque and potential energy. So torque is ml2 t minus 2 and potential energy is ml2 t minus 2. So the correct option is number D. Second question is, which of the following dimensions will be the same as that of time? Option A, C by L, B, L by R, C, R by L, and D, L, C. So here we have to find which expression has the same dimension as that of the time. So first let's identify dimension of the symbols. C, that is capacitance, have M minus 1, L minus 2, T 4 and I 2, where M is mass, L is length, T is time and I is current. Next, L, that is inductance, have ml2 t minus 2 I minus 2, and R, that is resistance, has ml2 t minus 3 I minus 2. Now for each option, C by L, if we put the value in it, so we'll get here m minus 2, L minus 4, t 6 and I 4, which is not equals to time. Next, L by R is equal to the time dimension. C is R by L. After calculating, we'll get here t to the power minus 1, that is inverse of time, and LC will get here t square. So the correct answer will be option number B, that is L by R. So question number 3 is, a truck accelerates at 1 meter per second square from rest. What is its velocity in meter per second at a time of 2 seconds? So the options are 2, 4, 1, 3. So given here our initial velocity u equals to 0 meter per second, that is truck starts from rest, then acceleration a is 1 meter per second square and time t is 2 seconds. Formula to find the velocity after time t is v equals to u plus at. Now the calculation is v equals to 0 plus 1 into 2, so the final answer will be 2. The velocity of the truck after 2 seconds will be here 2 meter per second. So the correct answer will be option number A, that is 2. Next, question number 4 is from the kinematics problem, that is, a stone thrown from the top of a building is given an initial velocity of 20 meter per second straight forward. Determine the time in seconds at which the stone reaches its maximum height. Take g equals to 9.8 meter per second square. Options are 2.8, 2.04, 1.67 and 2.7. So given here our initial velocity u equals to 20 meter per second upwards and acceleration due to gravity g equals to 9.8 meter per second square downwards. So we have to calculate here the time at which stone reaches the maximum height. So at maximum height, final velocity v equals to 0 meter per second, that is momentarily stops before coming down. So use the equation now, v equals to u minus gt. Now rearranged for time, that is t equals to u by g. Now calculate t equals to 20 by 9.8 will be equivalent to 2.04 seconds. So the stone reaches its maximum height after approximately 2.04 seconds. So the correct answer will be option number B, that is 2.04. Next question number 5 is a particle moves with constant speed v along a circular path of radius r and completes the circle in time t. The acceleration of the particle is, options are A 2 pi r square by t, B 2 pi r by t, C 2 pi v by t, and D 2 pi v square by t. We know acceleration is omega square r, so it will be v square by r, then omega v, then 2 pi by t into v. So the correct answer will be option number C, that is 2 pi v by t. Question number 6 is the maximum range of a gun of horizontal terrain is 16 km. If g equals to 10 meter per second, then muzzle velocity of a shell must be, option A 160 meter per second, B 800 meter per second, C 400 meter per second square, and D 200 root over of 2 meter per second. So given here maximum range r is 16 kilometer, that is 16,000 meter, then acceleration due to gravity g equals to 10 meter per second square, and the terrain is horizontal. Formula for the maximum range of projectile on horizontal ground is r equals to u square by g, where u is the muzzle velocity, that is the initial velocity, and angle for the maximum range is 45 degree. Now rearranged it for the u, that is u equals to root over of r into g. Now calculate u equals to root over of 16,000 into 10, so it will give 400 meter per second. So the muzzle velocity for the shell must be 400 meter per second. That is option number C is correct. Next question number 7 is two bodies of masses 10 kg and 20 kg respectively kept on a smooth horizontal surface are tied to the ends of a light string. A horizontal force F, that is 600 Newton, is applied to the 20 kg mass so as to pull it. What is the tension in the string? Options are A 300 Newton, B 200 Newton, C 150 Newton, and D 250 Newton. So let's solve this. Given is mass 1, that is m1, is 10 kg and mass 2, that is m2, is 20 kg. Force applied on m2 is F equals to 600 Newton. Surface is smooth, that is no friction is there. So the two masses are connected by a light string. Since both the masses move together, so the acceleration A will be equals to F by m1 plus m2. It will give 600 by 10 plus 20, that is 20 meter per second square. Now the tension pulls the smaller mass m1, so T equals to m1 into A, that is 10 into 20, it will give here 200 Newton. So the answer will be here option number B, that is 200 Newton. Next question number 8 is a particle of mass capital M is moving in a horizontal circle of radius capital R with uniform speed capital V. When it moves from one point to a diametrically opposite point, it's, option A, the momentum changes by mv, B, the momentum changes by 2mv, C, the kinetic energy changes by mv square, and D, the kinetic energy changes by half mv square. Now first understand the momentum change, that is P equals to mv. The particle moves with speed v but velocity changes direction. So initially velocity is v, at the diametrically opposite point velocity is minus v, that is opposite direction. So the change in momentum del P equals to P final minus P initial. So it will give M minus V minus MV. So it will give here minus 2 MV. So magnitude of change will be del P equals to 2 MV. Now let's see the kinetic energy change. So kinetic energy Ke will be here half mv square. Speed v remains same, so kinetic energy is constant, that is del Ke is equals to 0. So the correct answer will be option number B, that is the movement changes by 2 mv. Next question number 9 is consider the collision of two cars. Car 1 is at rest and car 2 is moving at a speed of 2 meter per second in the negative x direction. Both cars each have a mass of 500 kg. The cars collide inelastically and stick together. What is the resulting velocity of the resulting mass of the metal? Option A 1.4 meter per second to the left, B 1 meter per second to the left, C 1.2 meter per second to the left, and D is 1.5 meter per second to the left. So the given here mass of car 1 is m1, that is 500 kg, and velocity of car 1, that is v1, is 0 meter per second because it is at rest. Next mass of car 2, that is m2, is also 500 kg, and velocity of car 2, that is v2, is minus 2 meter per second because it's going in the negative x direction, means left. Now after collision, cars stick together perfectly in elastic collision. Now use the conservation of momentum, that is m1v1 plus m2v2. So we'll get here m1 plus m2 whole into v final. Now substitute the values in this, that is 500 into 0 plus 500 into minus 2. So we'll get here minus 1 meter per second. So here the negative sign indicates velocity to the left. So the resulting velocity is 1 meter per second to the left. So the correct answer is option number B, that is 1 meter per second to the left. Next question number 10 is a force acts on a 3-gram particle in such a way that the position of the particle as a function of time is given by x equal to 3t minus 4t square plus t cube, where x is in meters and t is in seconds. The work done during the first 4 seconds is, options are A 450 mj, B 490 mj, C 530 mj and D is 576 mj. So we know work done equals to change in the kinetic energy, that is kinetic energy final minus kinetic energy initial. So we'll get here half mvf square minus half mvi square, where v is dx dt is velocity. Now calculate the velocity as a function of time using integration. So we'll get here 3 minus 8t plus 3t square. Now calculate the initial and the final velocities, that is at t equals to 0 we'll get vi is 3 meter per second, and at t equals to 4 we'll get vf equals to 19 meter per second. Now convert the mass, that was 3 gram particle, into kg, that is 0.003 kg. Now calculate the work done, that is w equals to half of m, that is 0.003 into v square, that is 19 square minus 3 square. So we'll get the final answer here 0.528 joule, which is approximately equals to 530 mj. So the correct answer will be option number C, that is 530 mj. Next question number 11 is, a uniform sphere of mass 500 gram rolls without slipping on a plane surface so that its center moves at a speed of 0.02 meter per second. The total kinetic energy of the rolling sphere in joule would be, option A 5.75 into 10 to the power minus 3 joule, B 0.75 into 10 to the power minus 3 joule, C 4.9 into 10 to the power minus 5 joule, and D 1.4 into 10 to the power minus 4 joule. So for a rolling sphere, total kinetic energy is the sum of translational kinetic energy of the center of mass and rotational kinetic energy about the center of mass. That is, ke trans is half mv square and ke rotational is half I omega square. And we know moment of inertia for a uniform solid sphere is 2 by 5 mr square, and omega is equals to v by r. Now calculate the rotational kinetic energy, that is k rotational is half 2 by 5 mr square into v by r whole square. So we'll get here 1 by 5 mv square. Now calculate the total kinetic energy, that is k total is equals to k trans plus k rotational. So it is equals to half mv square plus 1 by 5 mv square. So we'll get here 7 by 10 mv square. Now substitute the values, that is k total equals to 7 by 10 into 0.5 into 0.02 whole square. Here 0.5 is the mass converted from gram to kg and 0.02 is the velocity. So we'll get the final answer is 0.00014 joule. So the final answer will be option number D, that is 1.4 into 10 to the power minus 4 joule. Next question number 12 is, the angular momentum of a system of particles is conserved, option A when two external force acts upon the system, B when no external impulse acts upon the system, C when axis of rotation remains same, and D when no external torque acts upon the system. So angular momentum of a system is conserved if and only if the net external torque acting on the system is 0. External forces alone don't guarantee conservation unless their torques sum to 0. Now external impulse or the axis of rotation conditions are not the fundamental criteria for the angular momentum conservation. So the correct answer is when no external torque act upon the system. This option number D is correct. Next question number 13 is, Two satellites of masses m1 and m2, where m1 is greater than m2, are going around the earth in orbits of radii r1 and r2, where r1 is greater than r2. Which statement about the velocities is correct? Option A, v1 equals to v2, b, v1 is greater than v2, c, v1 by r1 is greater than v2 by r2, and d is v1 is less than v2. We know for the satellites orbiting Earth, mass does not affect orbital velocity because gravitational force and the centripetal force both depend on mass, which cancels out. So the orbital velocity formula is v equals to root over of gm by r, where g is the gravitational constant, m is the mass of the Earth, and r is the radius of the Earth. Now velocity depends only on the radius of the orbit, inversely proportional to the square root of the radius. Since r1 is greater than r2, so v1 is equals to root over of gm by r1 is less than v2 equals to root over of gm by r2. So v1 is less than v2. So the correct answer is option number D, that is v1 is less than v2. Next question number 14 is, what is not conserved in the case of the celestial bodies revolving around sun? Option A, linear momentum, B, kinetic energy, C, angular momentum, and D is the mass. So we know in linear momentum the sun planet system is internal, but external forces like gravity from other bodies can act. Overall, a linear momentum of the whole system, that is sun plus the planets, is conserved, but the linear momentum of a single planet alone is not necessarily conserved because it moves in a curved orbit. Second, the kinetic energy is not conserved because as the planets move in an elliptical orbit, its speed changes, faster near the sun, slower farther away. Total mechanical energy, that is kinetic plus potential, is conserved in the ideal two-body system, but kinetic energy alone changes continuously. Third, the angular momentum of a planet about the sun is conserved, and last, mass of the celestial bodies is essentially conserved. So the answer will be option number B, that is kinetic energy is not conserved for the celestial bodies revolving around the sun. Number 25 is, a wire of length L and radius R is fixed at one end. When a stretching force F is applied at free end, the elongation in the wire is L. When another wire of same material but of length 2L and radius 2R, also fixed at one end, is stretches by a force 2F applied at free end, then elongation in the second wire will be, option A is L, B 2L, C L by 4, and D L by 2. So first here recall the formula for elongation of wire under stretching, that is del L is equals to FL by AY, where F is the applied force, L is the original length, A is the pi r square, that is cross sectional area, and Y is the Young's modulus, that is same for both the wires. Now for the first wire, L will equal to F into L by pi r square into Y, and for the second wire will be 2f into 2l divided by pi 2r whole square into y, that is fl by pi r cube y. Now comparing del L2 and del L1 will get here answer L. So the elongation in the second wire is L, the same as the first wire. So the option is A correct. Next, number 26 is, a uniform rod weight W, cross-sectional area A and length L is hanging from the ceiling of a room. The Young's modulus of the material is Y. The elongation of the rod is, options are 2 omega L by 3 AY, B omega L by 2 AY, C 2 omega L by AY, and D is 3 omega L by 2 AY. So the elongation of a vertically hanging uniform rod due to its own weight is del L equals to WL by 2 AY. But since the tension increases linearly from 0 at the bottom to W at the top, the average tension is W by 2. Correct answer will be option number B, that is omega L by 2 AY. Next question number 27 is, in a soap bubble pressure difference is, option A S by R, B 8 S by R, C 4 S by R, and D 2 S by R. So the correct answer will be option number C, that is 4 S by R. Next, number 28 is, a raindrop is released from a cloud that is 1000 meter above ground. When the drop is about to hit the ground, its speed will be, option A cannot be predicted, B constant terminal speed, C decreasing due to the retardation from the air drag, and D is increasing due to the acceleration due to gravity. So at the start the raindrop accelerates due to gravity. After some time the air resistance, that drag force, balances the gravitational force and the raindrop reaches terminal velocity, that is a constant speed. So just before hitting the ground the raindrop falls at this constant terminal speed. So the correct answer will be option number B, that is constant terminal speed. Next question number 29 is a cowboy fires a silver bullet with a mass of 2 gram and with a muzzle speed of 200 meter per second into the pine wall of a salon. Then assume that all the internal energy generated by the impact remains with the bullet. What is the temperature change of the bullet? Specific heat of the silver given here 234 joule per kg degrees Celsius, and the options are 83.50 degrees Celsius, B 81.50 degrees Celsius, C 85.50 degrees Celsius, and D 78.50 degrees Celsius. So the given here mass of the bullet, that is M, is 2 gram, that is 0.002 kg. Then initial speed is 200 meter per second and specific heat C is 234 joule per kg degrees Celsius. Now calculate the kinetic energy of the bullet, that is K equals to half mv square, and by putting the above value we will get here 40 joule. Now the heat Q absorbed by the bullet is related to the temperature change, that is del T by Q equals to mc del T. So del T will equals to Q by mc. Now put the values, that is 40 by 0.002 into 234, then it will be equivalent to 85.47 degrees Celsius. That is option number C is correct. Next question number 30 is on new scale of temperature which is linear called the W scale, freezing and the boiling points of the water respectively 39 degree W and 239 degree W. What will be the temperature on the new scale corresponding to a temperature of 39 degree C on the Celsius scale? Option A 139 degree W, B 200 degree W, C 117 degree W, and D 78 degree W. Since W scale is linear, it can be written as W equals to M capital C plus small c, where M is the slope and C is the intercept. Now for freezing point, W equals to 39, so equate the equation, that is 39 equals to M into 0 plus C. So we'll get here intercept 39. Now for the boiling point, 100 degrees Celsius equals to 239 degree W. So by putting this, we will get here 239 equals to M into 100 plus 39. So M, that is slope, will be here 2. Now write the conversion formula, that is W equals to 2 capital C plus 39, and calculate W at capital C equals to 39 degrees C. So W will get here 2 into 39 plus 39, that is 117 degree W. So the correct answer will be option number C, that is 117 degree W. Number 31 is a gas undergoes a process in which its pressure P and volume V are related as Vp to the power n equals to constant. The bulk modulus of the gas in this process is option A P to the power 1 by n, B number is Np, C is P by n, and D is P to the power n. So I have solved the problem as you can see here. So the correct answer will be option number C, that is P by n. Next, number 32 is which is an intensive property? Option A weight, B refractive index, C mass, and D is the volume. The correct answer will be option number B, that is refractive index. Next, number 33 is in kinetic theory of gas, a molecule of mass m of an ideal gas collides with a wall of vessels of velocity v. The change in the linear momentum of the molecule is option A mv, B 0, C 2 mv, and D is minus mv. So the initial momentum will be here Pi equals to mv, and the final momentum, that is it's going in reverse direction, that is elastic collision, P final will be here minus mv. So the change in momentum, that is del P, will be equals to P final minus P initial. So putting the values, will get here minus 2 mv. So the answer will be magnitude of the change in the linear momentum, that is 2 mv. So the correct answer is option number C, that is 2 mv. Next, number 34 is the ratio of the vapor densities of two gases at a given temperature is 9:8. The ratio of the RMS velocities of their molecules is option A 2√2:3, B 8:9, C 9:8, and D is 3:2√2. So given here the ratio of the vapor density of two gases, that is D1 by D2, is 9/8, and we have to find V1 by V2. that is ratio of the RMS velocities of their molecules. The relation between vapor density and the molar mass is D is proportional to M. So M1 by M2 is equals to D1 by D2 is equals to 9 by 8. And we know the RMS velocity formula is Vrms equals to root over of 3RT by M. So V is inversely proportional of root M. So V1 by V2 equals to root over of M2 by M1. So we'll get here root over of 8 by 9, that is 2 root 2 by 3. So the correct answer will be option number A, that is 2 root 2 is to 3. Next, number 35 is a spring 40 mm long is stretched by the application of a force. If 10 Newton force is required to stretch the spring through 1 mm, then the work done in stretching the spring through 40 mm is option A 48 joule, B 24 joule, C 84 joule, and D is 8 joule. So from the Hooke's law we'll get here F equals to Kx, where F is equals to 10 Newton and X is 1 mm, that is 0.001 meter. So K will be F by X, that is 10 by 0.001, that is 10,000 Newton per meter. And after that work done is half Kx square. So W will be half into 10,000 into 0.04 of whole square. So we'll get here 8 joule. So the correct answer will be option number D, that is 8 joule. Next, question number 36 is a body is executing SHM when its displacement from the mean position is 4 cm and 5 cm. The corresponding velocities of the body are 10 cm per second and 8 cm per second. Then the time period of the body is option A 4p second, B 3p by 2 second, C 2p second, and D is p second. Here p is pi. So the displacements x1 and x2 are 4 cm and 5 cm. Similarly, the velocities are v1 and v2 are 10 and 8 cm per second. So the velocity in SHM is v equals to omega root over of a square minus x square, and here omega is 2 pi by t, which is the angular frequency. So at x equals to 4 cm, velocity v1 will be equals to omega root over of a square minus 4 square equals to 10, and for x equals to 5 cm, v2 will be equals to omega root over of a square minus 5 square is equals to 8. Now divide both the equations to eliminate omega, that is v1 by v2 equals to root over of a square minus 16 by root over of a square minus 25. So we'll get here 5 by 4. Now square both the sides, that is a square minus 16 by a square minus 25 equals to 5 by 4 whole square, that is 25 by 16. Now after solving all this we get here a square equals to 41. Now use the first equation to find the omega, that is 10 equals to omega root over of 41 minus 16. So we'll get here omega equals to 2 radian per second. So the time period will be here 2 pi by omega, that is pi seconds. So the correct answer will be option number D, that is pi seconds. Next, question number 37 is two waves represented by y1 equals to a1 sine omega t and y2 equals to a2 sine omega t plus delta, and del is equals to pi by 2 are superimposed at a point at a particular instant. The amplitude of the resultant wave is. So first use the trigonometric identity for y2, that is sine whole omega t plus pi by 2 is equals to cos omega t. So y2 will be equals to a2 cos omega t and y1 was a1 sine omega t. So the resultant displacement is y equals to y1 plus y2, that is a1 sine omega t plus a2 cos omega t. And now this can be written as y equals to a sine whole into omega t plus phi, where a is equals to root over of a1 square plus a2 square and tan phi is equals to theta 2 by theta 1. So the amplitude of the resultant wave is a equals to root over of a1 square plus a2 square. So the correct answer will be option number C. Next, question number 38 is a stretched string is vibrating according to the equation, that is y equals to 5 sine pi x by 2 cos 4 pi t, where y and a are in centimeter and t is in seconds. The distance between two consecutive nodes on the string is, options are 4 cm, 8 cm, 16 cm and 2 cm. So the part sine pi x by 2, which means k equals to pi by 2. And now calculate the distance between the two consecutive nodes, that is nodes occur where sine kx is 0, which means kx equals to n pi. So x will be here n pi by k, that is n pi by 2, that is equals to 2n centimeter. Then distance between two consecutive nodes will be here xn plus 1 minus xn is equals to 2 whole n plus 1 minus 2n will get here 2 centimeter. So the correct answer will be option number D, that is 2 centimeter. Next, number 39 is electric energy between two bodies can be produced by sticking, rubbing, passing AC current and de-oiling. So the answer will be option number B, that is rubbing. And last question of the physics section is number 40, that is when air is replaced by a dielectric medium of dielectric constant K, the maximum force of attraction between two charges separated by distance, option A remains unchanged, B is decreases K times, C decreases K square times and D increases K times. So the force between the two charges in a medium with dielectric constant K is given by F equals to 1 by 4 pi epsilon naught K into Q1 by Q2 by R square. Since dielectric constant K is greater than 1, the force decreases by a factor of K compared to the force in the air or the vacuum. So the correct answer will be option number B, that is decreases K times. That's the wrap for all the physics questions from the SVNIRTAR CET paper. I hope you found these solutions helpful and easy to follow. If you enjoyed the video, don't forget to like, share and subscribe for more exam preparation content like this. Also drop your doubts or suggestions in the comments. And thanks so much for watching. Now good luck for your exams.